All right, no heat pipes here. Vapor chamber coolers. Let's see how these stack up. Welcome to Machines and More. Haven't heard from Cryorig for quite some time, but apparently they're still around. And this guy is one that many of you have asked about. I finally got my hands on both the full copper version and the regular black, the non-copper heat fin version. So big thanks to Cryorig for making the review possible by providing these test units. But I did want to reiterate that I don't do paid reviews here on this channel. So what you see is a product of my independent testing and research. Cryorig C5 coolers feature a vapor chamber based heatsink. The heatsink looks a lot like a 1U server cooler. Very low profile, 28.6 millimeters tall, and they are paired with a proprietary 90 millimeter RGB fan. This one has a max RPM 3200 RPM or so. This will add about 25 millimeters of height, and there's a portion where the frame will extend past the heatsink to clip onto the heat fins. So that's why it's a little bit thicker, but it's not actually going to add that much height. It is a very small cooler, and the intent here is going to be for small systems, small form factor systems where height is a limitation. Otherwise, I don't see why you would go out of your way to get small coolers like this, right? So with fans installed on this cooler, they're just shy of 54 millimeters tall. Vapor chambers work similarly to how heat pipes do, in that they rely on phase change between vapor and liquid to move the heat away from the heat source and then transfer that heat to the heat fins, where the fan can then exchange the heat with the surrounding air by blowing through the heat fins. So instead of a solid block of copper with heat pipes running through it that touches your CPU's IHS, you have a vapor chamber contact plate here. And this section is square and machined with a spiral pattern. The copper heatsink measures in at 428 grams, while the regular one is a lot lighter at 245 grams. And for reference, the Thermalright AXP90 X53 full copper comes in heavier than this one at its 504 grams. The C5 CU is spec'd at 180 watts TDP, and the regular C5 is 165 watts, and I wouldn't take any stock in those numbers since those numbers are typically never grounded in real-world utility or fan speeds. But the limitation of this type of vapor chamber design won't be how much thermal mass it has, which it's pretty hefty, but if the vapor chamber is not able to conduct the heat away from the CPU effectively, then ultimately it will not matter at all if I have a huge amount of heat fins over it, right? And where the heat pipe design is more effective is when you want to make the unit taller. So for example, with the AXP90 X53, the fin stack is a lot taller, and I can do that because the heat pipes are running into that section and the bottom section and transferring heat evenly throughout the fin stack. So although both coolers ultimately arrive at a similar height, the Thermalright accomplishes that by using a bigger heatsink and a slim fan versus the slim heatsink and the thick fan of the Cryorig. The cooler can work with Intel 115X, 1200, 1700, or LGA 1366, and that uses this plastic backplate and screws through the cutout holes that you see on the corners. For AM4 and AM5, it's a little bit different than what you might be used to seeing because it's going to screw into the stock backplate, which is pretty normal. But because of the form factor of the heatsink, you only have these small semicircles at the top and bottom edges, and that's where the screws will pass through, so they don't make full contact with the heatsink. With a small footprint, you shouldn't have any issues with fit on most ITX boards. RAM is not an issue either. It doesn't overlap. So in this category, you do have a few coolers that fit a similar form factor, but in my experience, the Thermalright AXP90 X53 is going to be one of the class leaders. So that and the shorter X47 are very, very popular with our sandwich style case builders. So it is a very good comparison, and I'm using the X53 full copper as I think that is the most direct comparison both in height, the fan size, and material. So I don't have an exact market price yet, but I do recall from Computex it is somewhere around 60 to 70 US for the full copper version. So for testing, I test with actual CPUs in actual cases to give you a real-world representation of the performance that you can expect. So I first started out testing on the 14600K in the FormD T1v2, like we talked about in the last video. That CPU is a really, really good deal right now, but I don't think this cooler is anywhere near appropriate for it since it's just too much power for this cooler. But I did want to test with an LGA 1700 CPU and get an idea how the vapor chamber works with that IHS size, because that also will have implications for the Core Ultra 2 IHS. So where I first mounted it up, I gave it a run through. It throttled and reduced power to only about 117 watts. So I set a manual limit of 115 watts. I tried to do a noise normalized comparison here to match the C5CU to the AXP90 at full speed, but the C5CU was still throttling. So I basically had to lift the fan speeds quite a bit past the same noise level to get it not to throttle. So here, what you see, not only is the AXP90 significantly better, it's also about 4 dBA quieter. So not great. One other thing I noticed was that when I let the fan curve float, the fan RPM varied a lot at idle, and you'll hear that quite often. The fan would spike and get really loud. I did a little digging to see why that was, and I charted out the temp at a more micro level. And this is a 1-minute sample of the idle temps at a 20 ms polling interval. So I tried to get the idle temps to fall within the same ballpark, and that's why the Thermalright fan is so much lower, because the C5CU fan still has to run quite fast and audibly even for idle operations. But what you notice here is a lot more variance because you see quite a few spikes, and that may come down to how the vapor chamber is able to respond to variations in that heat load. And you'll notice that despite the variation in the package power being quite similar between the two test cases, almost identical, the C5CU exhibits a much greater standard deviation in response to that, and that's going to lead to more erratic fan behavior if you use the CPU temp as a reference temp. And also, one thing I would recommend that you do if you are intending on using this cooler, just to see if your motherboard has a setting to dial down the sensitivity of your fan RPMs to that temp response. That'll help smooth out those fan spikes. But in general, I didn't get the impression that this is well optimized or well suited to the larger IHS size for LG 1700 or 1851. And I think the size of the vapor chamber will potentially need to be bigger for the power and the size of the IHS. So while the thermal performance suggests a huge gap here against the AXP90, I really think that's mainly due to the vapor chamber size just not being well suited to that IHS. The AM5 IHS, however, is a lot smaller than the surface area of the newer Intel one, so I wanted to test it with a lower power CPU and smaller IHS to hopefully noise normalize so I can get a direct comparison. So I used the 7800X really running in my Fractal Terra at around 75 watts for a heavy multi-core CPU render. And here I did see the performance of the C5 a little bit closer because the max temp of the 7800X really is 89, so here we still hit the max temp. And then the CPU dialed back on power draw to about 3 watts lower compared to the Thermalright. So I still then did also test with ramped up fan speeds to try and see if I can get it to not throttle, but I still got a similar throttled result at the same power delivered. So I really think the limitation is with the vapor chamber and what it's able to transfer to the heat fins. One thing you might find interesting, the regular C5 performed about the same. So I don't think the thermal mass is the issue here. And where I found some success getting a noise normalized result was in an FPS limited gaining scenario. So pretty limited scenario. I had to make sure that the CPU ran a very meager 36 watts. And in this scenario, the noise normalized gap between the AXP90 and the C5CU is about 7 degrees. So once again, this regular C5 actually performed practically the same, if not slightly better here. So if you were expecting that either of these coolers would come close to their stated TDP measurements, I do hate to disappoint you, but from my testing, that does not appear to be anywhere realistic. I think this cooler would only be suitable for 65 watt TDP AMD CPUs like the 9600X or 9700X, and even then, it can be easily outclassed. These coolers come with proprietary fans with a built-in clip, so while I think you could rig up your own 92mm fan on this with like a zip tie or something like that, I'm not sure what the value added would be since the fan doesn't seem to be the limiting factor. But this fan can go up to 3200 RPM with some variance. I found the noise profile to be very average. It was very loud, and here's a quick sample. Okay, so the performance from my evaluations, not the best. The Thermalright AXP90's those are going to beat these pretty handily. And while at first the idea of the vapor chamber seemed kind of unique and it looks cool, yeah, it looks really cool, right? A lot of the thermal performance seems to be limited by the reliance on the vapor chamber. Now, it's got a thick fan, but I don't get the impression that it's able to take advantage of that extra airflow. And due to the reliance on the vapor chamber, they can't make this fin stack taller, since that wouldn't be effective without the heat pipes to, deliver the heats evenly into the heat fin. So it just seems like this is in kind of a weird position design-wise. So where this design may make more sense is perhaps if we're targeting an even lower height. So with the limitation of the heatsink, I feel like a slim fan wouldn't be a bottleneck here. So potentially this could go down to 43 or 44 millimeters thereabouts with a slimmer fan. And there we might start to make sense, because then you're comparing against a different class of cooler then. And where I am curious is if this design can be combined with a few heat pipes, and that may help to alleviate some of the deficiencies at the thicker height. But as it is, the AXP90 X53 full copper is around 35 to 36 US. The non-copper heat fin version is just a tad over 20. So if you're faced with this level of height limitation for your build, I just don't see why you wouldn't go that route, given that the expected pricing is going to be significantly higher for the C5 series. These can work with some low power CPUs, but I think you would really need to have a specific reason to opt for these instead. So curious how they might seek to redesign this. So yeah, that's that. Novel concept, and I do have to applaud them for absolutely trying something different here. So I hope you found the review helpful and informative. Please give a like. Make sure you're subscribed. Have links down below for the components. And big thanks for watching today.